Alright, so in this problem we're going to take a look at how a change in volume and temperature have an effect on pressure. We've done this problem numerous times with numbers, but in this case we're going to actually do it just relatively in terms of changes to the size and the relative change in the temperature. So gas with a pressure of 3.2 atmospheres is moved to a vessel that's 1/3 the size of the original, kept at a temperature that's 1/2 what the original was. What's the new pressure of the gas? Alright, so the first thing is, because we're dealing with a change in variables and we're not just trying to find one given the rest, we need to use the P1 V1 over N1 T1 equals P2 V2 over N2 T2 equation. And if you look at it right here, we're given absolutely no information on the moles. So we're assuming that's the same gas. No one has said anything about us losing gas or gaining gas. And therefore, what we're actually going to do is we're going to cross out the N1 and the N2. And so going forward, we're just going to have to P1 V1 over T1 equals P2 V2 over T. And now we need to start plugging these things in. So if we take a look at this, we need to figure out, first off, what do we put in for V1 and V2? We're not given a numerical value. So the way we're going to deal with this is we have a relative value, right? So we know that V2 is equal to 1/3 of V1. And if we look at the temperature, that's half, so we know that T2 is equal to 1/2 of T1. So you can see right now that we're not actually going to need numerical values, because we can go ahead and plug in for this V1 and T1 on the right, as long as we use these fractions of them, and solve it. So I'm going to set this up, therefore, that the pressure 1 is 3.2 atmospheres. We know that much. And then we know we have V1 over T1. And this is going to be equal to pressure 2, which is what we're trying to solve for, times, I'm going to sub in for V2, 1/3 V1. And I'm going to sub in for T2, 1/2 of T1. Alright, so given that, we can then go ahead and rearrange and solve for P2. So P2 equals, and now what's going to happen here is we're going to pull up T1, 1/2 T1 will go to the top, right? I'm going to multiply both sides by that. 1/3 V1 is going to go to the bottom. I'm going to divide both sides by that. And so with a little bit of rearranging, what we're going to end up with is this. We're going to have 3.2 atmospheres, which is the P1, times, and V1 stays on the top, but notice that now 1/3 V1 is on the bottom, and that is multiplied by, in this case, the 1/2 T1 comes to the top, and the T1 stays on the bottom. Now I think you can see our strategy here, right? V1 over V1 is 1, cancels out. T1 over T1 is gone. So really what we're left with is 1/2 over 1/3 times 3.2. Okay, so in other words, if we were to just rearrange that, it's going to be 3.2 atmospheres times 3 over 2. Okay, do that out. It's going to be 4.8 atmospheres. Now, obviously, if we had number values for all this, we would just plug them in for V1, T1, V2, T2, and do it quite simply. This one's a little more complicated because you have to use the variables, but you can see that it's the relative change in temperature and the relative change in volume that matters here, not the direct value of the volume and the temperature, because we're dealing with a change and not trying to find a set of moles at a given set of conditions.